see. Yes. Hi, everyone. My name is Tyler Morganwall, and yes, I'm going to be talking today about the R package ray shader. Let's see. So Ben already gave you a little introduction. Mostly, this is just to give you a picture of my Twitter profile picture, because we all look a little different on Twitter. We all look at a little different also when we're 1 centimeter tall on your laptop. So this is what I actually look like, but that's what I look like on Twitter. So I'm the developer of 4 packages, 3 of which are currently on the CRAN. Ray Shader, Skipper, and Ingested CRAN logs. Ray Focus I'm going to get on eventually. It has some features in Ray Shader, but this is me, and this is what I do. So I'm going to answer a few questions in this talk. First and foremost, what is Ray Shader? Why did I develop it? And how can you use it to make beautiful maps and visualizations? Secondly, I'm going to spend a few minutes talking about 3D plots, or about 3D plots and why they aren't as bad as some people make them out to be. And finally, I'm going to talk about some of the non-coding activities you can do to develop your projects and how you can take advantage of the great online RStats community. So, Ray Shader is a package designed to make maps in R. And by making maps, I mean taking the topographic data and using that to make a map, as opposed to taking somebody else's tiles and putting spatial data on top of that. By creating maps straight from the source data, the source elevation data, you can control all of the aesthetic qualities of your maps. So, if you use base R, this is what you get when you plot elevation data. Now, this is Hobart, Tasmania, but it kind of looks more like 2 amoebas fighting in pond scum. So this is the Ray Shader version of the plot with the function sphere shape. So the code is on the left and the output is on the right. So it's, in my opinion, a much more naturalistic view of the data. While you lose the direct mapping of color to elevation, you gain a much more human understanding of the topography. Note how details appeared that weren't in the base R plot, namely the fact that there is a river between these 2 mountains. So Ray Shader is built around elevation data, and building a map is very similar to how you build a plot in ggplot. So here I've added a water layer simply by calling detect water, which detects the water in an elevation matrix, and then add water, which layers it on top of whatever layer image you're feeding into it. And you can continue this. Ray Shader's name comes from the fact that it uses ray tracing to shade maps. So here we added a ray trace shadow layer, again, just by calling in the Hobart, it's a base R matrix. There's no special spatial data structures here. It's just a matrix. Into ray shade, which determines if each point is in shadow or light. That returns an image file, and add shadow layers that on top of the previous image. So we can continue stacking different types of shadows. So this is a ray trace layer. This is what's called an ambient occlusion layer. Ambient occlusion just models the amount of the horizon showing at a certain point, which basically makes valleys darker than ridges. So this adds a nice texture to the map, I think. And here, so we have a very nice, beautiful 2D map. But if you think about it, our base data is actually already 3D. We have X, Y, and our elevation Z. So what we do is we just map this image straight to the elevation data. So note here, in all of this code on the left, the only data going into this is the matrix of elevation values. So, and because it's so simple like this, you can focus entirely on the aesthetics of your map rather than having to worry about dealing with other aspects. So Ray Shader comes with multiple built-in palettes. I think I currently have 7 in. But it's really easy to customize your own. There's a function called create texture where you just specify the highlight, shadow, accent colors, and it will create a texture where you can then feed it into and work on what you want your map to look like. So each palette comes with its own matching watercolor, but again, that is something you can just easily customize by passing in, let's say, a hex code for the color or a color name in R. So something that bothered me when I first made this plot, I mean, it's really cool, but it's representing solid ground, but it's infinitesimally thin. Even though it's representing Earth, it looks like something that you could just blow away if you breathe too hard. So I made it so you could set solid equals true and create a solid base with a nice shadow, something that you could imagine picking up and putting at your desk and fidgeting around with. Make it look like a real object. Which then got me thinking, well, it'd be nice if you didn't have to imagine that. So here on the top is the output of RayShader, plot 3D, and the bottom is the output of the function save 3D print. This isn't the output of the function. This is the output of the function reading to a file, sending to a 3D printing service, waiting 2 weeks, and having for that to be mailed back to me. So this is Hobart, Tasmania again. But note how closely they match. I mean, it didn't match exactly because the thing wasn't turning exactly evenly. But note how closely they match. And I actually matched the colors at the top one. I created my own custom texture to map the kind of reddish, tannish color that came from the red background. And making this, I found out when I truly made it as an R programmer. This is when my cat was finally interested at what I was doing on the computer instead of just trying to get in front of the computer. So also, none of the built-in data sets in R really showcased, I think, some of the cooler features of RayShader. So I actually added, I took from USGS data and found this data set of Monterey Canyon, which is a combined bathymetric and topographic data of Monterey Bay, California. And this, I think, really starts to show where RayShader really shines, which is combined topographic and bathymetric data sets. And this is important because our planet is going through an enormous period of change, and much of that change is focused along our coasts. So one of the main goals with RayShader was to make it dead simple to model and visualize visualizations with land and water. Here, all the user has to do to model a changing coastline, which, you know, that might be in the news, is to set it in the plot 3D function. Just literally set the height of the water, and it changes it. And RayShader does all the heavy lifting. And you can also model it after the fact with a render water function, so that just layers it on top. So there's a good visualization needs context. I mean, it's nice to have pretty maps, but you need to have something to provide the reader some sort of idea of what's going on. So just last month, I pushed an update where you could add labels to your maps. And the render label function is actually very simple because all you need to do is provide the row and column index for where your label is, and RayShader will then automatically put that part there. And you actually get the altitude of the plot of the text label in the units of your map. So that I set it at like a couple miles above the surface. But it's really simple to label your plots. So this is serious. This is not. So this is serious. So you can actually put down real data on top of your maps. This is the add overlay function. Now, as a developer, I've just been developing it, so I actually haven't been really using it for GIS stuff. So I've been mostly using this to throw animated GIFs on top of my maps. So I particularly like this. One of the issues I had with the raw output of the 3D functions, and this is just in general a problem you get when you're dealing with computer graphics, is that they looked kind of CG. And I really wanted to look like a real model. So one way to do that is to make it look like it's being imaged by a real camera. So I actually built into RayShader a virtual camera that all you need to do is specify your focal point and your actual virtual camera properties, either f-stop or focal length, and it will then take that image you have and then render this beautiful bokeh effect with your map. So it's really super simple to make stuff that looks fantastic, in my opinion. And finally, starting next week, I'm pushing an update that will allow users to create arbitrary shaped 3D maps, simply by setting the points in the elevation matrix to NA, which is very simple as APIs go. So you can make arbitrary map shapes without really having to worry about any sort of special weird API. And RayShader handles all of the intelligent slicing of both the water and land areas. So that is the current state of RayShader. And there's a lot of cool stuff that's coming. I hope people that will like. But I think there's one feature that I think a lot of people are really excited about, and that's 3D ggplots. So I'm not actually going to talk about this feature in particular right now, but because I'm still working on it and there's still a few bugs I need to work out. But what I am going to talk about is the small contingency of people who think I should not even release this feature because 3D plots are always bad and they just inhibit interpretation, and generally they're categorized as chart junk. So are 3D plots always bad? No. This 3D plot's bad, yes. But are 3D plots always bad? No. The idea of 3D plots being bad really comes from the fact that when people think of a 3D plot, they usually think of a gratuitous 3D plot, meaning like 3D pie charts or bars stacked, where the data itself is not actually 3D. But when the data has a legitimate 3D mapping, creating a 3D plot is perfectly fine. There's also the idea that since the display medium is 2D, like in a book, let's say, that a 3D plot only exists to, or only make the plot less interpretable. But here, I think, are two examples from the USGS, the Atlas of Oblique Maps, published in 1988, that contains beautiful representations of topography in 3D. And unlike a 2D contour or color map, you don't need to be a cartographer or to have a color bar to understand what's going on or the landscape. This is immediately interpretable by a layperson. And some might say, well, actually, okay, fine, yes, that's interpretable, but that's more of an illustration. That's not a data viz, snobs. But actually it is. They actually, in the 1988, they didn't really have the computing power we use, so they used tools. This maps actual contour maps, it's called an isometrograph, to 3D contours with the elevation scale on the right. So that's what they used to construct these plots. So they used they got these plots actually from data. So even in 1988, cartographers understood something very important about 3D maps. They are incredibly, or 3D visualizations in general, is that they are incredibly engaging and they're very easy to understand. And this type of engaging tool is very important when trying to communicate complex ideas and analyses about our changing planet. In particular, I want to point out the last sentence, or those two sentences there, because I think they're pretty, coming from 1988, we still have the same issues today. And the last sentence actually says, well, with the help of computers, maybe someday this will be possible to do this more easily. So I think RayShader fulfills that computer quality. So I think We've come full circle. The cartographers can write about me in their next Atlas of Oblique Maps. So finally, each visualization, or not finally, each visualization is part of a story, and sometimes the idea that a visualization needs to take a backseat to the exact representation required by the data, or that needs to take a backseat to the story you're trying to tell. So this visualization was not made with RayShader, but I think it's a really great example of a 3D visualization that tells a story. In this case, the amount of changing groundwater in Southern California by showing how the ground is breathing, that a still, even set across in different frames or plotted on its own, a 2D visualization would not be able to capture or engage. I mean, this is a story about groundwater that I went like, ooh, cool. So in this case, if a picture is worth 1,000 words, I just think that a 3D animated figure, it must be War and Peace. So, and sometimes you specifically do not want the viewer to try to interpret your figure. Sometimes you just want, so this is actually the daily closing stock price of Yahoo, visualized as a cityscape. But you can't tell that because I specifically did not include it, the label, which is in the upper right. And because sometimes you just need a splashy title slide. And as a highly paid professional, you know you don't use generic clip art. So you need to show how much you're worth by taking your data and making a very splashy visualization. That also avoids the number one question that presenters presenting analytical work don't want to hear at the end of a talk, which is, hey, can you go back to your title slide? I have a question on the data there. So finally, I'm going to talk a little bit about developing your project using things other than coding. Writing about your projects is more than just marketing. It can be a great tool to brainstorm. So here I wrote that I didn't want the map, this is writing about 3D plotting. I didn't want the map to look like a carefully crinkled sheet of paper. I wanted a 3D representation that looked like a paperweight. And this is what actually got me thinking, like, wait, what would it take to make that possible? So in this case, writing actually inspired a feature development, which I then wrote another blog post about. So it really is a great way to get yourself in a self-introspective mode and think about where you want to take your project. Creating animations is fun, but it's also a great form of testing your software. So this actually, you see a little bug that I've encountered when plotting the add label function, or testing the add label function. You see how the label disappears at certain angles, but not all angles. And I actually didn't notice this problem until I started making these animations for Twitter to show off the features. So it's a great way to test your software and more than just marketing. And finally, speaking of the RStats community and posting on Twitter, it's an incredible resource that you can use. In particular, it can get you three things. First is, of course, inspiration. Ozzy Jimbob, Twitter, he's actually the first guy that combined my ray tracing with spherical shading, and that's where I saw that and went like, oh, that's where I need to take this project. David Waldron, he showed how much of a city is in light and shadow during certain parts of the year. More cool animations, South Pacific data, pollution in India. David Waldron again, he's very talented. Showing flying, paragliding in the UK, and just lots of cool things that are just inspiring to see. It's very cool when you have, I can think of cool things to do with my software, but I'm not nearly as creative as dozens or hundreds of creative people also working on the same thing. So it helps drive your project in places maybe that you don't know it's going to go. Secondly, there's shame. So it's painful but necessary. If you ask the internet, like, hey, I want to make a ray tracer to shade topographic maps, you're likely to get a bunch of people saying, like, hey, it's trivial, just go to Wikipedia, that'll tell you how to do it, or Stack Overflow, why figure it out yourself. But if you tell the internet, hey, I've done something really cool, I've made a ray tracer to shade topographic maps, you'll get every pedantic, beautiful person coming out of the woodwork to tell you exactly what you did wrong. And if you can stomach it, you can actually use that to drive the development of your package, which I added a bunch of features based off of Hacker News. Don't go to Hacker News. But it was great. Bug fixes, of course. We all don't like to see it, but it's good. You got to find them out somehow. Performance shaming. Sometimes programming stuff like making your programs more efficient or faster is necessary, but it's not really fun to do. So I had a blog post that was 100% written about how slow RayShader was. I saw that and I was like, okay, I'll make it faster. And so I made it faster. And that actually helped because there are some things that I started doing recently that would not have been possible if it was still that slow. And finally, just motivation. This is just an excerpt from the last month of people saying like, wow, we're really interested in what you're doing. And there's nothing more joyful than seeing people loving and showing interest in what you're doing. So if you have any projects that you're working on that you're really proud of, I would definitely say post it, especially to the hashtag #RStats community, because I don't think you'll find a more supportive programming community out in the internet. So in summary, make maps. Don't be afraid of 3D plotting. Write about your projects. It can help you more than you think. And be sure to tweet your heart out. Thank you very much. Oh, and I have this map here. If you want to see it after the break, I can show you the 3D.